Welcome dear student. Today we will revise our electricity chapter, and you can see these questions in your screen. These questions are last solved 10 year papers questions. Okay, so you can say this thing that from 2010 to 2019, okay, only these question came in a board examination. So try to solve these questions. If you face any kind of difficulty, you can ask. Okay, now at first go through first question. This is a what does an electric circuit mean? Okay, we have to explain about the electric circuit. As we know, an electric circuit means a closed and continuous path through which an electric current flow. Okay, that type of electric circuit in which is a closed and continuous path through which an electric current flow. No problem in this one. Now second question is define the unit of current. As we know, I equal to q upon t. Okay, from this we can define the current. We can say the rate of flow of charge is called current. The rate of flow of charge is called current, and its SI unit is an ampere. Okay, this is the answer of our second question. Now move to question number 3. You can see here, this question is calculate the number of electrons constituting 1 coulomb of charge. As we have formula about charge, which is q equal to n into E. Okay, so in this question it is asking about the number of electrons. It means we have to find out this n. Okay, so from this formula we can get n equal to q upon E. Okay, we have a charge which is 1 coulomb, and the value of E is 1.6 into 10 to the power minus 19 coulomb. This is a charge on an electron. Got it? The charge on an electron is 1.6 into 10 to the power minus 19 coulomb, and we have given Q, which is 1 coulomb. Okay, Q 1 coulomb, and number of electrons we have to find out. Then by this formula, okay, we will divide this one. By dividing this term, we get 6.25 into 10 to the power 18, or you can directly memorize this one. Okay, because this is really very important question. Now next question is name a device that helps to maintain a potential difference across a conductor. Okay, so battery, or you can say cell, this is used to maintain potential difference across a conductor, due to which an electric current flow in a circuit. Now next question is, when is the potential difference between 2 points said to be 1 volt? So as we know that V equal to W upon Q. Okay, this is a formula for electric potential, and if we talk about potential difference, then formula is same. VA minus VB equal to W upon Q, we can write it. Okay, so by this formula we can make definition, or you can say the potential difference between 2 points in a current carrying conductor is said to be 1 volt if 1 joule of work is done in carrying a charge of 1 coulomb between the 2 points. Suppose there are 2 points, okay, and the work done to move a charge from this point to this point is 1 joule. Okay, suppose the work done is 1 joule in carrying a charge of 1 coulomb between these 2 points. So the potential difference is 1 volt. Now you can see question number 6 here. This one, how much energy is given to each coulomb of charge passing through a 6 volt battery? Okay, V is given 6 volt. Each coulomb of charge, it means that Q is 1. Q is 1 and V is 6. Okay, so by using V equal to W upon Q, as I already told you, this is a formula for electric potential. Okay, we have V, which is 6 volt, and Q 1 coulomb, so we can easily find out the value of W. Okay, now next question. This question is also very important. Okay, it is asking frequently in board examination. How is voltmeter connected in the circuit to measure potential difference between 2 points? As we know, this voltmeter device is connected in the circuit to measure the potential difference, okay, between 2 points. So always remember this point, that we always connect voltmeter in parallel combination, okay, in parallel combination. It can ask about ammeter also. You should know ammeter always connected in the series combination. Got it? And one other important question is what is the resistance for ideal voltmeter, and what is the resistance for ideal ammeter? You should know the resistance of ideal ammeter is 0, and the resistance of ideal voltmeter is infinity. Okay, infinite you can say. Now, another one, question number 8. Why tungsten is used almost exclusively for filament of electric lamps? As we know, electric lamp works on the principle of heating effect of electric current. So, for this purpose, we need high resistivity material. That should have two important property. Number one, it should have high resistivity, and its melting point should be high. So these two properties followed by tungsten. That's why we use tungsten for the filament of electric lamps. Okay. Now next question is this: list any two factor on which resistance of conductor depends. As we know that resistance depends on mainly length and area. This is directly proportional to length and inversely proportional to area. So these two are the important things. Now next, resistivity we have to define. Okay, as we know from this formula, R equal to rho L upon A, this is resistivity. So we can get formula for resistivity, which is RA upon L. So okay, from this formula we can make the definition of resistivity. Okay, resistivity of any substance is equal to the resistance of a conductor of unit length and unit cross section area. Okay, if L equal to 1 meter and A equal to 1 meter square, then we can say rho equal to R. So from this we can make definition of it, that the resistivity of a material is the resistance of a conductor of unit length and unit cross sectional area. Okay, now next one, define 1 watt hour. 1 watt hour. Okay, as we know 1 watt hour, watt hour, okay, it means watt is a unit of power, hour is a unit of time. Okay, P into T. So this is a unit of energy, or you can say work. Okay, watt hour is a unit of energy. So we can make a definition of it, that this is a energy consumed by an agent of power 1 watt in 1 hour. Okay, so this is very important thing. Now next one, you can see a cylinder. This is a numerical, and this is very easy numerical, we can easily solve. In this question we have given a length of a material and cross sectional area 2 centimeter square, and resistance is also given. We have to find out resistivity. We should know this formula. We will put all these given values in this formula and we will get our answer. Okay, now in this question you have to see that the unit of length is centimeter in every case. So our answer is in ohm centimeter. If I ask to you that what is a unit of resistivity, then your answer should be ohm meter. This is a SI unit of resistivity. But in case of this question, as we can see here, the unit of length is given in centimeter. Got it? Now in next case, this is also important question. Okay, you can see here, state which has a higher resistance, a 50 watt or a 25 watt lamp bulb, and how many times. As we know, we have a formula for P equal to V square upon R. Okay, from here we can say that R equal to V square upon P. It means that resistance is inversely proportional to power. Okay, so 25 watt lamp has more resistance or 50 watt has more resistance. Okay, if this value is less, it means this value is high. So we can say in case of 25 watt lamp, it has high resistance in compared to 50 watt. Got it? And it is also asking about how many times, as we can see from this relation that R is proportional to 1 upon P. Okay, you should know this thing that you are using two different bulb, okay, which has reading of 25 watt and 50 watt. Then you should know this thing that which has less power, because voltage is same, we are applying same volt, okay, which is 220 volt for India. So at constant voltage, the resistance is inversely proportional to power. Okay, this is directly proportional to 1 upon P. It means that the when power will increase, resistance will decrease. Okay, so we can see here the value is 25 and 50 watt. So we can say 25 watt lamp has double the resistance of 50 watt lamp. Okay, now in next question you can see here there are two electric bulbs marked 60 watt to 20 volt, marked 100 watt to 20 volt. Which of them has high resistance? Okay, voltage is same, so we can apply the same formula. Then this is the same formula. Then R proportional to 1 upon V. P, as we know, which has lower power, okay, that will have more resistance. So in case of 60 watt lamp has more resistance than a 100 watt lamp. Now go through this one also. Draw a systematic diagram of an electric circuit consisting of battery. Okay, so we can easily draw it of two cells, 1.5, 5 ohm, 10 ohm and 15 ohm. Okay, so this is a question you can see here. So this is a diagram, because we always connect them in series, and I think you are now able to know about the series combination. So this combination is series combination. You can see all resistances are in series combination. Okay, this is a key how to join in a circuit, we should know. Okay, now next question is, why do we use copper and aluminum wire for transmission of electric current? As you know that it has low resistivity and these are good conductor of electricity. Okay, so these are some important questions related to electricity chapter. Go through it, dear student. If you face any kind of difficulty, then you are free to ask, okay, any questions. Thank you very much. Okay.